So in this video, we're going to talk about limiting reactant. We're going to start with a silly example of trying to make a cheeseburger. Okay, so for instance, what if I had 3 hamburger patties, okay, and 4 hamburger rolls, and 2, 4, 6 pieces of cheese, and 1, 2, 3, 4, 5, 2, 4, 6, 7 tomatoes. Okay, how many hamburgers can I make? Cheeseburgers can I make? Well, I can make 3 cheeseburgers because that's how many hamburger patties I have. And each cheeseburger needs a hamburger patty. So when I'm left over, I used 3 of these, so I have 1 roll left. I used 3 of these, so I have 3 pieces of cheese left. And I used 2 of these on each sandwich, so I have 1 tomato left. Okay, so my limiting reactant is the hamburger patties because it limits how many cheeseburgers I can make. Okay, I had enough rolls to make 4 of them. I had enough pieces of cheese to make 6 of them, and I had enough tomatoes to make 4.5, 3.5, I think. Okay, but I only had enough hamburgers to make 3. That's my limiting reactant. It limits how much of a product I can make. So think in terms of a reaction. 2H2O plus O2 gives you 2H2O. What's your limiting reactant here? Well, these little guys are your water, are your H2s, and the big guys are your O2s. So for every 2 hydrogens and 1 oxygen, okay, can you see what you're going to need here? I've got a total of 1, 2, 3, 6 O's, because they're O2s, and 1, 2, 3, 4, and 8 H's. Okay, so you can see that you can make 4 H2O's, and to do that you used 8 H's, and you used 4 O's. So can you see that the H's were what limited how many waters you could make? And you have 2 O's left over, right? So if you look at your diagram, you managed to make 4 waters, and you have 2 O's, or an O2, left over. So what's your limiting reactant? The H2s, because they limited how many waters you could make. You had enough O's to make more water, but not enough H's. So what if we look at this? We want to take some H's and some N's, and the reaction is H2 plus N2 gives me ammonia. So first thing I'm going to do is balance that. Okay. And then I want you to look at that diagram and decide how many NH3s can you make, what's your limiting reactant, and how much excess will you have left over. So I want you to pause the video for a second and see if you can figure that out. Okay, so I'm going to assume that you paused the video for a second and tried to figure that out. But I have 3 N's, so I can make 3 NH3s. Okay, as long as I have 6 H's available, right? 1, 2, 3, 4, 5, 6, and I do. So I'm going to make 2 NH3s, and I'm going to have 4 H's left over. Okay, but hopefully you know that H's aren't really like that. I really am going to have 2 H2. Okay, so this is left over. Right? So my limiting reactant is my N, and my excess reactant is my H. Okay, so then let's try some problems sort of less picture-like. So 2 moles of nitrogen react with 2 moles of hydrogen. What's the limiting reactant? So if I have 2 moles of this and 2 moles of that, can you tell which one you're going to run out of first? I think it's pretty simple just to look, right? Since you start with the same amount of each one, but you need more hydrogen, can you see that you're going to run out of hydrogen first? So hydrogen is your limiting reactant. Okay? And then how many moles of ammonia is produced? Well, if I start with 2 moles of hydrogen, do my mole ratio, okay, moles of hydrogen to moles of ammonia, which is 2 to 3, which is 1.33 moles, I could make that many moles of ammonia. Okay, let's just check our work here. If I'd started with 2 moles of nitrogen, okay, do my mole ratio, which is 2 to 1, okay, I had enough nitrogen to make 4 moles of ammonia, but I have enough hydrogen to make 1.33 moles of ammonia. What that tells me is that this is my limiting reactant, and this is the amount that I actually make. Okay? This is not true. That's not going to happen. Okay, so you can start with each amount and figure out how much product each would make, and just choose the smaller one. Limiting reactant takes a little more time, but it's not particularly difficult. So 2.56 moles of nitrogen reacts with 7.54 moles of hydrogen. How many moles of ammonia will be formed? So I know it's a limiting reactant problem because I have the amounts of both reactants. So I'm just going to do my math twice. 2.56 moles of nitrogen. Okay. How many moles of ammonia could I make? So I'm going to do my mole ratio, 2 to 1. Okay, and that looks like I can make 5.12 moles of ammonia. Okay, if I start with 7.54 moles of hydrogen, and I do my mole ratio, right, 2 to 3, that comes out to 5.03 moles of ammonia. Okay, pick the smaller one. This is the actual amount that I will make. It's called the theoretical yield. This is incorrect, and this is my limiting reactant. Okay, so be careful. Just because I started with less ammonia or nitrogen doesn't mean that that's the limiting reactant. You have to do the stoichiometry out and figure out how much product you would make. It would have been tempting to assume that was what you're going to run out of first, but it's not. Okay, last one. Let's do it in grams now. 10 grams of nitrogen reacts with 3 grams of hydrogen. How many grams of ammonia will be formed? Ideally, you would stop the video right now and try this first, and then check your work with me. So why don't you go ahead and try it. Again, I'm going to go ahead and assume that you stopped the video and tried it, because that would be good policy. But if you didn't, I can't do anything about it. So I'm going to change grams of nitrogen to moles of nitrogen. And then my all-important mole ratio, so moles of nitrogen to moles of ammonia. Okay. And then we're going to change moles to grams. So nitrogen N2 weighs 28.02 per mole. There's a 1 here and a 2. Remember, that's the stoichiometry from the coefficients. Okay. And ammonia weighs 17.04. Okay. So that gives us 12.2 grams of ammonia. All right, now we have to do the other one though. Okay, so we're going to start with 3 grams of hydrogen. Okay, we're going to change grams to moles. 2.02 for hydrogen. We're going to do our mole ratio. Okay, for hydrogen there's a 3, for ammonia there's a 2. And then again, we're going to change moles to grams. 17.04 for ammonia per mole. And that gives us 16.9 grams of ammonia. Okay? So it's important that you don't just stop there. It's important that you recognize this is the amount that you make, the theoretical yield. Okay? This is not correct. And nitrogen is your limiting reactant, and hydrogen is your excess. So that's how you do limiting reactant problems.